Hi, this is Mrs. Robertson, and today in my fifth period class, we're going to discuss histograms, go over our math boxes on page 34, and then we're going to learn about outliers today and how they affect the mean, median, mode, and range of our data. All right, first of all, though, our math boxes on page 34. We have to write a statistical question about Old Faithful, and we've already had a little discussion on this. A good statistical question would be about how long is a typical eruption? So let's write that down. About how long. Now you could have had other things written here, but it has to be a question, which means it ends in a question mark. You can tell there are just all types of lengths as to how long the eruption would last. All right. What would you say is the peak of this graph? It really sort of has two peaks, doesn't it? Two areas where it goes to the top. What's one area that you would consider? Yes. Yeah. Between the 1.8 and the 2.1, that's the highest point. And this one is it's close, okay? Then it sort of has a gap or it goes down. We don't really have none of the ones that are this duration, but it goes down. But that would be the peak right there. That, and then you might say that over here would be one too. All right, now let's go to question number 2. Finn has 1 4/5 cups of trail mix. Aiden has 1 3/10 cups of trail mix. How much more trail mix does Finn have? Well, Finn has more, so we're going to put Finn's amount on top. 1 4/5 minus Aiden, which is 1 3/10. But as you can tell, we can't subtract these because they don't have the same denominator. All right? So we have to find a common denominator. What's a common denominator between a 5 and a 10? What would it be? Yes. Yes, we're going to change them to tens. Okay. This is 3/10, and we have to change it. 5 times 2 is 10, so 4 times 2 is 8/10. Now we subtract. 8/10 minus 3/10 is what? Yes, 5/10. So he has 5/10 more. What's another name for 5/10? We usually don't say, oh, I have 5/10 more trail mix than so-and-so. What would you say? Yes, 5/10 is the same thing as 1/2 a cup. All right, now we're going to look at the next one and determine which ones are true and which ones are false. Now, in math box 3A, is that true or false? That one is true, yeah. 4 times 420 is the same thing as 420 times 4. That is true. Put a T. Is 4 times 420 the same thing as 8 times 210? Well, 4 times 420 is 1,680. 8 times 0 is 0. 8 times 1 is 8. 8 times 2 is 16. They do equal each other. You need to go remove yourself if you're going to continue to cough, please. We're recording this video. Please leave. You can come back in a moment. In letter C, 4 times 420. 4 times 0 is 0. 4 times 2 is 8. Does 1,680 equal 1,660? No, it's false. This one is true because they took the 0 from behind and put it over here. So it will equal the same thing. They both equal 1,680. It's true. Are there any questions? We're not going to answer number 4 for right now, but we're going to go back to page 33. So once you have this all written down, let's go to page 133. Or page 33, not 133. Now, on this page, we have 2 histograms, and they represent the same amount, the same thing. They both are about final exam scores. What's the difference between these 2 histograms? What makes them different? Yes, in the back over there, yes.
They have like different numbers and different test scores.
Yeah, their intervals are different. Here, they went from 20 to 30, 30, they went by tens. But here, instead of going by tens, what did they go by? 25. From here to here, it's 25. Yeah, the intervals are much larger, okay? There's a big difference between 10 and a 25, okay? So, but they still have the same amount of the things in them. Let's see. How many people did they question here? Well, this one's 2. Write this down, 2. That's a 15 and an 18. So add them all together. So over here, let's write down 18 plus 15 plus 2 plus 2. You got to add those together. And then we're going to add the ones up over here on this side. This is 1 plus 2 plus 1 plus 2. That's a 6. That's a 9. And this is a 13. That's a 5. So over here, we're going to add these. We should get the same answer. So let's add these together. All right, so I have a 13, a 9, 6, 5, 2, 2, 1, and 1. We're going to add those all together and see what we get. Okay, 13, 14, 15, 16, 17. Carry a 1. Did you get 37? What do you get for the other ones? Well, it has come to Mrs. Robertson's attention that I made a mistake. This was not 15. In between a 16 and an 18, that was 17. So this should have been a 17, making that not a 37, but a 39. Now, did I write all of these numbers down correctly? 13 plus 9 plus 6 plus 2 plus 1 plus 2 plus 1 plus a 5. And when you add those together, do you get a 39?
Yes.
Oh, so much better. All right, 39. Okay. Now, let's go to question 1. Describe the distribution of the histogram on the left. Well, most of the data is on the right, wouldn't you say? So let's write down most data on the right. Now, kids, we describe that as being skewed to the left. That's called skewed to left. Now, that is on iLearn in 6th grade. They will ask you, is it skewed to the left or skewed to the right? I never could remember which way to go until this. When you have that, you make it a dinosaur. Here's the head of the dinosaur. Okay, there's its teeth. There's its head, and here's its tail. It's got ears. All right? The way that the tail lands is where it is skewed. So which way is the tail? The tail is on the left. It's skewed to the left. That's how I figure it out. I make it a dinosaur, and wherever the tail, if the tail's on the left, it's skewed to the left. If the tail is on the right, it's skewed to the right. Can you remember now how to do that? Just make it a dinosaur, and the way that the tail is on tells you where it is. Describe the distribution in the histogram on the right. Well, it's heavily weighted to the right, correct? Most data, in fact, almost all data is on the right. Yeah, it's like almost all of it is on the right on that one. Okay? Any questions? Why are the graphs different shapes? Think about it. Write something down. Why are the graphs not? Why are they? Okay. Why are they different? Well, what's the bottom? What are they? Yeah. Why are they different? We call these groups intervals or bins. They have graph 1 has how many intervals? We'll call this graph 1 and this graph 2. Graph 1 has how many intervals? Has 1, 2, 3, 4, 5, 6, 7, 8 intervals. And graph 2 has how many intervals? Graph 2 has 4 intervals or bins. Okay? Oh, we've already answered the question to 4. How many test scores are represented in each one? What did we get? How many test scores are represented in this? Yes.
There are 39.
39. How did you find the number of test scores? What did we do to get that number? Yes. Add all the heights. Add the numbers. I guess we could call it add the height of each interval or each bar. Add the height of each interval. Okay, kids, we do not get up out of our seats without permission when Mrs. Robertson's teaching. Go sit down in your seats. Now, for the next part, we're not going to do this because it would have to be an estimate because we don't know the exact numbers. We have no idea how many numbers are in between, what the numbers are that are here. So we're just not going to do that problem. I don't think it's really a worthwhile thing. So you can put an X through 5 and an X through 6. Close your math journals if you have that finished. Pass them down to the right, and the person on the right will put them back in your box. We have a video. It's going to talk to us a little bit about outliers.
And how they may affect measure center. An outlier is when one data value is much greater or much less than the rest of the data values in the set. An outlier may affect a measured center. Determine how the outlier affects the median and the mean in the following quiz scores: 55, 88, 90, 93, 94. Let's first identify the outlier.
Okay. The first thing you do with the data set is you put them in order from little to big, which they are done. They put them in order from little to big. The outlier is a number that's much smaller or much larger than the other numbers. Which number is much smaller or much larger? 55 is much smaller than an 88. All the others are close together. So 55 is considered the outlier of the data. Any questions on that? That's the thing that I want you to learn about first. So now I'm going to give you a worksheet, and we are going to practice finding outliers on this paper. But the first thing you're going to do when I give you the paper is you have to put them in order from little to big. So on this problem here, our smallest number is 15. So you're going to put down 15. Then the next number is 20. There are two 20s. The next number is 25, and you have 1, 2, 3, 4 25s. You write it down 4 times. Then the next number is going to be 30, and then 65. You can tell that 65 is much larger than 30. 15 is still close to 20. So your outlier is 65. So that's what you're going to do on this page is you're going to put them in order from little to big, and then you're going to circle your outlier. All right, so most of you should have these finished. The answer for the second one, your outlier is 0. 0 is much smaller than all the other numbers. In this problem, you put them in order from little to big. 295 is your outlier. In this one, from little to big, 361 is your outlier. In this problem, 14 is your outlier. And in the last group, 229 is your outlier. Now, this is one that the kids always get. So, if we wrote down the ages of everyone in here, including Mrs. Robertson, your ages are all going to be really close together, aren't they? Mrs. Robertson's age is going to be a big outlier. I'm not even going to be close to you because I'm in my 60s. Mrs. Robertson would be in the 60s, and you kids are all like in the 10s, 11s, right? Aren't most of you like 10? Difference. Now, if you were in Mrs. Sacco's room, she's in her 20s. Now, she's still an outlier compared to you, isn't she? But she's not as big of an outlier. Mrs. Robertson's a bigger outlier than anyone else in the hallway. Yes. Okay. The outlier sticks out. It's either much bigger or much smaller. So like in this one, all of the numbers are really pretty close. But 229 is over 100 away from 332, the next number. But 352 is only about 3 away from 349. So it sticks out. It's either much larger than all the others or it's much smaller. Like Mrs. Robertson's age is much larger than all of the other ages in here. So that's what an outlier is. Okay? Now we're going to go to the back side of the worksheet and we're going to do the questions that they have. All right? It says, an outlier can affect the mean of a data set. Answer each question. We're not only going to compare it to the mean, we're going to compare it to the median and the range. And we could say the mode, but the outlier never affects the mode, just FYI. All right. So on this group of numbers, let's put them in order from little to big. Okay, I'm going to give it to you so we can save some time. 83 is our smallest number. 164. 168. Then we have 174. 179. 183. Make sure you're writing these down. 180. Ooh, we have two 183s. That's our mode in the list here, isn't it? 195, 197, and 204. Okay. 204 is pretty close to 197, isn't it? Is 83 close to 164? No, 83 is our outlier. Now it says, what is the mean of the data set? Well, kids, when you do the mean, let's just put a few notes up here. You add and divide, right? So to get the mean, you add and divide. Okay? Now, on this group, when you add all of these numbers together, I'm just going to tell you so you can save time, you're going to get 1,730. How many numbers are they? What are we going to divide by? Yes. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're actually going to divide it by 10. So the mean of our data set, 1,730 divided by 10, says the mean is 173. Does 173 look like it sort of blends in with those numbers? Yeah, it does. Okay. The next problem, what is the mean without the outlier? They want you to kick out the 83. Well, if you kick out the 83, you're going to have 1,730 minus 83, and that gives you 1,647. What am I going to divide 1,647 by? Am I going to divide it by a 10 if I kick it out? How many numbers am I going to have? Yes. Divide it by 9. Okay. So, let's do that. 1,647 divided by 9. 9 goes into 1 no times. 9 goes into 16 once. Subtract. Bring down. How many 9s are in a 74? 8. That's 72. Subtract. Bring down. How many 9s are in a 27? 3. So, the mean for this one is 183. Without the outlier, our mean is 183. Now let's answer the next question. Without the outlier, that means this answer, did the mean increase or decrease? Is this number larger or smaller than what the mean was earlier? Yes. Yes, it increased. So, kids, excuse me, when your mean is smaller and you kick it out, that means your mean, whenever your outlier is smaller than the others, you kick it out, your mean will increase. Okay? If your outlier is bigger and you kick it out, your mean will decrease. Okay? Now, let's see how the outlier affects our median. Now, we're going to do that down here, median. Median is your what? Middle number. So, here we have with our outlier, let's see, we have bloop, 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 bloop. We have two middle numbers. And what is halfway between 179 and 183? You add them together, divide by 2, and you're going to get 181. So our median right now in that list is 181. Okay? Now, without the outlier, if you remove the 83, so I'm going to put WO Oh, without outlier, our median is what? Well, let's get rid of that. I'm going to cover it up right now with the orange. Now our median is bloop, 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 bloop. It's 183. Okay. Did throwing out the outlier affect the median? Did it affect it a lot or just a little bit? Just a little bit. So let's write that down. Just a little bit. That's one of your questions on the test. When removing the outlier, does it affect the mean or the median the most? It affects the median just a little bit. Did it affect the mean? Yeah, it changed it by what? 10. Do you know what it affects the most? The range. Let's talk about the range. Okay. With the outlier, my range is going to be 204 minus 83. Okay? 204 minus 83 is 121. Okay? Now, if you remove the outlier, then it's going to be 204 minus 164. Here, the range is only going to be 40. So it affects the range the most, right? Yes. Does the outlier affect the mode at all? No. The mode is 183 with or without the outlier. Okay? Now, this is what I want you to do for your classwork, and if you don't get it done in class, it's homework. I want you to do this problem here. Put them in order from least to greatest. Find the mean. Then find the mean when you throw out the outlier. Did the outlier make it bigger or larger? When you threw out the outlier, did it increase or decrease? Do those questions, and then I want you to do the median, then find it for the median. Do the median, and then the median without outlier. And if you have time, you can do the same thing for the range. Find the range, and then the range without outlier. Once you're finished, turn it in, and then you have no homework. If you don't get this finished, then you'll need to take it home and bring it back. This will be worth 10 points tomorrow, so make sure you turn it in. Don't lose it. Yes. Yes, you may.